Okay, so to start this, we know that cosine of theta is 3/5. So what we do is cosine of theta equals, because we know ka toa, we know that ka is cosine, it is adjacent over hypotenuse, which we know cosine is 3/5. So that equals 3/5, which is adjacent over hypotenuse. So from there, we draw a triangle so that we can use the Pythagorean theorem to find out the missing side, because from here we only know two sides. So we know that 3 is adjacent and 5 is hypotenuse. So we do the Pythagorean theorem, which is 3 squared plus x squared equals 5 squared. So we know that the missing side is 4. Okay. We will start with sine. So we know that sine is the so in SOHCAHTOA, which is opposite over hypotenuse. So we take the opposite, which is 4, and we simply put it over the hypotenuse. Now because there is a domain restriction in this equation up here, we have to find out whether it is negative or positive. So the domain restriction is that it has to be greater than 3 pi over 2, which is right here, and less than 2 pi. So that we know this is the only place a triangle can be. So we know that this is cosine, and it's a positive, and this is sine, and it's a negative. Okay, so because we know sine here is negative, this sine must also be negative. See? Next we have tangent. So we know that tangent is sine over cosine, or TOA, opposite over adjacent. So we can just do from here opposite, which is 4, over adjacent, which is 3. Now because we don't know whether it's a positive or negative, we have to use sine over cosine. Up here we know the domain restriction. This is sine, which is a negative, and cosine is a positive. And a negative divided by a positive is a negative. So we know that tan is negative. The next one is cotangent squared. So cotangent is also tangent. It's cotangent is basically 1 over tangent. So what we do is we have to flip tangent. We know that tangent is 4/3, and the opposite of that is 3/4. So from there we know that cotangent is squared, and because the number is squared, we have to square both the number on top and both the number on bottom. So it actually equals 9/16. But this is the tricky part. Because there is a domain restriction, which again is 3 pi over 2, we have to find out whether this is positive or negative. Now because it's cotangent squared, any number squared, whether it is positive or negative, turns out to be positive. So for any question that asks for a squared, is going to be positive no matter what. Okay, so moving on. The next question is secant. So we had learned that secant is basically cosine, just reversed, 1 over cosine. equals secant. So, because we know what cosine is, it was given to us in the beginning, we can just flip that. So that is 5 divided by 3. Okay, so secant is 5 divided by 3, and we still don't know whether it is positive or negative. But we do know that cosine is positive. So we transfer that cosine is positive to secant is positive because nothing changes, really, except for the numbers are flipped. Because cosine is still adjacent over hypotenuse, our cosine is still positive, secant would still be positive. The next question is, we'll do cosecant squared. Cosecant squared. Now cosecant, just like secant was, cosecant is the opposite of sine. So 1 over sine equals cosecant. So we take sine and we flip it to get cosecant. So that is 5 over 4. Now because we know that sine is a negative, and we know that transfers to cosecant as a negative, but cosecant is squared. So that means it will always be a positive. So there will not be a negative here. But it is squared, so the numbers do have to be squared. So the answer is 25 over 16. Okay. Last part is sine squared. Now we already know what sine is. We already solved that in the very beginning. All it's asking is for sine to be squared here. So what we do is we take the negative 4/5 and square it. And because negative times the negative is a positive, then there will not be a negative here. But it will be 16 over 25 because 4 was squared and 25 was squared. There you go. And we will try that with a second problem. Okay. Now here, we know that sine of theta is negative 9 over 11. So, using SOHCAHTOA, we know that sine of theta equals SO, which does equal negative 9/11. And equals opposite over hypotenuse. So we draw our triangle just like before, and we plug in 9 for opposite, and 11 for hypotenuse. Now we don't need to transfer the negative sign. We'll do that when we do our circle. We can find out whether it's a negative or positive because we know sine is negative. It has to be, sine has to be negative here. That's a negative. And sine has to be negative here. Because these two portions, this makes sine positive and this makes sine positive. Those can't be true. So, shoot. Okay. So we have to do the Pythagorean theorem to solve for this leftover side. So 9 squared plus x squared equals 11 squared. Which is 81 plus x squared equals 121. X squared equals 40, and x, so then x equals the square root of 40. And because this asks for the exact simplified value, we have to find the simplified value of square root of 40, which we just take 40 and find that simplified value. Now we know that this is all the square root of 2 times 2 times 2 times 5. Well, 2 times 2. 2 times 2 is 4, and we know that the square root of 4 is 2. So we can put that on the outside. 2 times 5 is 10, and there's no square root in there. So the simplified version is 2 square root 10. So we're going to start with cosine. So using co, which is cosine, we know that we use the adjacent over hypotenuse. So adjacent of cosine is 2, 10 over hypotenuse, which is 11. Now here, we don't know whether it's positive and negative, but we do have a domain restriction, which is the same as before. So we do the same thing as before. And this can be the only possible triangle. So what we do is we know that the cosine is positive and sine is negative. So we have cosine here, we have cosine here, and we know that it's positive. So we just leave it be. The next problem is tangent. So we know that it is using SOHCAHTOA, opposite over hypotenuse. So we take the opposite and put it over the hypotenuse. Now for this one, we still don't know whether it's positive or negative. So we know that tan is also sine over cosine. So we go up here, and we look at sine, which is a negative, and we put it over cosine, which is positive. And we know that a positive divided by a negative, just like the previous one, is a negative. The next problem is cotangent squared. So we did this one before, and we know that cotangent is basically the opposite of tangent. It is 1 over tangent equals cotangent. So what we do is we transfer this, but we flip it. So it is 11 over 9. And because the negative times a negative is a positive, this is not a negative. But it is squared, so we do have to square both 11 and a 9, which is 121 over 81. The next problem is cosecant squared. So we know that cosecant is basically the opposite of sine, which is up here, our very first given. So we take sine and we flip it just like we did with cotangent and tangent. And we get 11 over 9. Okay, so this one starts with cosine. We're given cosine. So cosine, we're using the SOHCAHTOA. We know that cosine equals co, which is adjacent over hypotenuse, and we know that from up here is negative 2/7, which is adjacent over hypotenuse. So, like always, we draw the triangle so we can use the Pythagorean theorem to find that missing side that we don't know. And we know that 2 is adjacent and 7 is the hypotenuse. And again, the negative sign doesn't carry down because using the Pythagorean theorem, you square everything and everything would end up positive. So what we do is we take 2 squared plus x squared equals 7 squared. X squared equals 4 plus x squared equals 49. And x squared equals 45. X equals square root of 45. So, like it said before, we need to find the exact simplified value. So we do that same thing we did last problem. We take 45 and we find the roots. Okay, so we know that it's 5 times 3. The square root of 45 is basically the square root of 3 times 3 times 5. And we know that 3 times 3 is 9. And there is a square root of 9, which is 3. So that goes here. And there's a square root that evenly comes out from 5. So the missing side, which is equivalent to the square root of 45, is 3 root 5. So from there, we know that there is, in fact, a domain restriction. So let me go ahead and do that. The domain restriction is different this time. It is pi over 2. It has to be greater than pi over 2. And it has to be less than 3 pi over 2. So it has to be one of these two quadrants. Because we also know that cosine is negative. To double check, this in fact is negative. So this is the right quadrants. So from there, we're going to start with sine. Sine is so in the SOHCAHTOA, which is opposite over hypotenuse. So we take the opposite, which is 3 root 5, and we put it over the hypotenuse, which is 7. Now we don't know whether this is positive or negative. And this one is trickier because there is 2 triangles. So what we do is we check. There is a positive sign and there is a negative sign. So this is tricky. Instead of putting whether it's positive or negative, you have to put both. So it is positive or negative. Okay. And that only happens when there's 2 triangles. There's 2 triangles. There are 2 different options. So the next problem is tangent squared. Tangent squared. So we know that tangent is the TOA in SOHCAHTOA, and it's the opposite over the adjacent. So we're going to do that again, which is the opposite is 3/5 over, and then the adjacent, which is 2. Now this is tangent squared. So we can go and find whether it's positive or negative, but it won't matter because any number squared is positive. So we're going to completely disregard that for just this problem. So, but we still have to square 3 root 5 and 2. Then we know that 3 root 5 is the exact same thing as the root 45. So we're just going to take 45 and square that, and that equals 45 over 4. So the next problem is cotangent. And cotangent is, again, like all the previous, the opposite of tangent. So we're going to basically flip that. But we're not going to use this one because that's tangent squared, and we're only looking for tangent. So we take this problem, which is 3 root 5 over 2, and we're going to flip it. So it's 2 over 3 root 5. Now we're going to find out whether this is positive or negative. So we're going to go back to tangent, and we know that that's sine over cosine. So we're going to go sine, which is a positive, over cosine, which is a negative, So we know that it has to be a negative. But there is another triangle here. And sine here is a negative, and cosine here is a negative. And a negative divided by a negative is a positive. So we know that cotangent can be both positive and negative. So you have to write plus or minus. Next problem is cosecant, which we know is the opposite of sine. And we know sine, so we basically just take this and flip it again. So we do 7 over 3 root 5. And we have to keep the positive and negative, because we know that that goes in hand with the equation. So it's positive over negative. And the next problem is secant squared. So secant squared, as we know, goes hand in hand with cosine, which was our original given. So we take our cosine, which is negative 2 over 7, and we flip that. So we get 7 over 2. Now because it's squared, we don't need to take that negative, because any negative times a negative is a positive, as we know. But again, secant is squared, so we do have to square both 7 and 4. So we get 49 over 4. And our last problem is sine squared. Now we already had sine. That was our first problem we found. And it is the exact same one. You carry this down. So it's 3 root 5 over 7. And because this is squared, you have to square this part and this part. And because it's squared, we know that a positive times a positive is a positive, as well as a negative times a negative is a positive. So this stays a positive. So 3 root 5 is the same thing as the root of 45. So we're just going to take and square the root of 45, which is 45, and then square 7, which is 49. That's it.